Good evening, everyone, and welcome to the Cohere Labs Open Science community. I'm Arya Sanish, and I'm here with Prahita and Vaibhavi, and we'll be your hosts for today's session. Today is super special for us. This session marks the launch of our ML industry program, and we are starting with our first guest talk. And before I introduce our speaker, I would like to briefly share about why we started ML industry. So the goal of ML Industry program is to help our members build a strong foundation for research in the industry. Many of us in our community are career switchers, early career researchers, and academics. And some of us are looking to transition into industry roles, while others want to partner more effectively with industry research. And both paths need the right guidance, resources, and feedback. This program is designed to provide exactly that. Instead of focusing narrowly on one niche, we are building a broad framework that covers the skills and mindsets essential for long-term career growth in AI. And here's the structure that you can expect moving forward. So we'll be having talks with leading researchers from top labs on frontier ML topics, workshops led by engineers on implementing papers, building product features, and making API-level optimizations. And we'll also have interactive panels with researchers from multiple companies to guide you through career decisions. Our aim with this is to expose you to the thought process behind impactful research, the skills that translate research into products, and the career philosophy needed to succeed. Now let's get started with today's session. We are thrilled to begin with today's topic, crafting a successful AI career and transitioning research into scalable AI products. In this talk, you'll learn how to make strategic career moves in AI, build production-ready agentic AI systems, think at a systems level to deliver business impact, and grow technical depth while sustaining your career long-term. Our speaker, Nikhil Pentapalli, is a senior machine learning engineer at Adobe. His work spans document intelligence, generative AI, and large-scale NLP systems. Nikhil has led end-to-end development of AI features from research prototypes to production-scale systems. He has spoken at O'Reilly events and other forums, sharing insights on applied ML and research to product transitions. He also holds a master's in computer science from the University at Buffalo. Beyond his technical expertise, Nikhil is passionate about mentoring aspiring ML professionals and helping them navigate the fast-changing AI space. We are very fortunate to have him here with us for this launch session. Over the next hour, Nikhil will share practical strategies for building an impactful career in AI and how to bridge the gap between research and real-world products, including the emerging agentic world. With that, let's welcome Nikhil Pentapalli to Cohere Labs Open Science community. Welcome, Nikhil.
Thank you, Arya. That was really great introduction and great opening. And I really love how the community receives me. And I'm really glad that the initiative Cohere took, for this ML industry program should be worth it and will be worth it. And looking forward to it. And thanks again for Vaibhavi and Prahita as well for, inviting me over. And with that, we'll get started. Awesome. Let me share my screen.
Yep, go ahead.
All right. Hope you can see my screen. All right. All right. Hi, everyone. Welcome. Today's session would be mostly focusing on career pathways and real-world production challenges. Since Arya gave a lot of introduction about me, I would just skip that. So I'm an ML engineer at Adobe working on Gen AI features. But today we'll be discussing about something different, that how do you take your research into a product, like a full-scale product. So we are talking about something like taking from 0 to 1. What are the obstacles that we face today? And then because the AI is moving so faster, even the research is moving faster, and the production have to cope up with that, and then vice versa. So how research alone can't create an impact, right? So how do you convert that research into production? And then how do you scale it? And so that it creates an impact around the world. So we'll talk about that. We'll cover a few topics around it. So this will be the today's agenda, and by the end of this talk, you'll have an understanding and framework like how do you think about taking up research into a product, and how do you actually get into the career of ML in AI space. So again, first of all, welcome everyone, and we'll be just discussing on a very high level what sort of roles are out there, right? So irrespective of any role here, the final thing that in as an industry person or as who's working at big tech or any startup is looking for is some of the key contributions and how can we create an impact overall with the existing product, or how can we take that research product and then create an impact out of that product. So there are a couple of roles like research scientist, applied scientist, MLE, and data scientist, product manager, and more. But the idea is a product can be built only when all the people, right, ML engineer, applied scientist, research scientist, everyone works together, um, and come together, define some sort of product requirements, and then finally getting that research POC done and in initial level, get it to production. So generally, this is how the transitions will look like on a very high level. But this is the thing, like everyone is needed. So it's always not like applied scientist or research scientist or ML engineer is itself enough. We need a whole team to make things work. So given that, as an industry professional, one thing that's really needed for career growth or career growth is basically not just your technical expertise, but you have to make sure you are visible out there, like what you're doing basically, or both on personal level and professional level. So how do you do? And by the way, I'll just stop here because this session is not going to be about this. This session is going to be more about along with the case study, we'll go and in depth and understand how production systems work. This is just a high level. So because as I know there's a multiple audience out there from different streams. So it would be very beneficial for every one of you. And coming back to this, so not just technical expertise is needed, but you also need to showcase your ability of networking through, you can basically publish some blog post, share on your LinkedIn, speak at some events, contribute to open source. And also these impactful contributions help you with quantify your outputs basically, and inputs and outputs. So you can't just say like I have 95% accuracy, right? So what does it create? What is the impact that it creates? How much latency did you optimize for? What is the X and what is the Y? So you have to make sure you are clearly communicating a story out there, and that's very important in your career growth. So these skills are definitely not going to be like over one day or 2 days. They'll take time, but it creates a compounding growth over time. Again, everyone has their own career trajectory. There's no specific career path. For example, you could be building a YC company, maybe sometime this month, you can just come up with an idea. Or you could be more of an AI researcher, publish a paper that is groundbreaking, that something like a transformer, attention is all you need, or transformers papers. And then that creates a completely new world. And you could be a thought leader, you could be advising a few companies, you could be working on AI agent infrastructure building, or you could be more of an academic and research publications, or you could be a professor or a PhD grad. So there are so many career paths. Again, everything has its own benefits, everything has its own way. It's completely up to each individual who what to choose. And the reason I'm bringing this up is because a few of these roles are definitely industry related, a few of these are research related, and both of them are needed to get a good product that is impactful out there. Now, I know there might be some students or early career professionals, or someone who's looking to switch or land a role in AI. So what do you basically need from an industry point of view? Understand what sort of role are you applying for. Is it more of a research oriented role, or is it more of a product oriented role, or is it engineering role, or is it a deployment infra related role, or ML ops role, LLM ops? What is it basically? What's the role, the definition of that role or job description, understand it, see how you can fit into it, or maybe that fits with you. And then first of all, you need to, any irrespective of anything, you need to have like a strong foundation, understanding the basic concepts, the tools, the libraries, and domain specific knowledge at a ground level again, because as these Gen AI era is still relevant, and people are directly working on LLMs without understanding what a transformer is. So, and I have particularly seen this happening. So it's always good to go through the basics and then go through few research papers, understand the basics, and then come back. Also, master the why you pitch. So there'll be so many people applying for the single role. How are you different from them? So you have to make yourself different from them. So highlight your experiences and make them convey as like a good story. Showcase your projects, show your LinkedIn, show your GitHub profile, or show your open source contributions that speak for themselves. And make sure you're prepared, mock interviews, because the real interviews are completely different, but mock interviews can get you to a stage where you're completely prepared. And then finally, network and make sure you're visible. So let's say if you're doing n number of things, but only 10 people around you know about that. So, but let's imagine that if you are posting and you're public, you're talking, you're public, you're doing publications, you're doing a lot of collaborations, you're contributing everywhere. So people all around can see you, and then you don't know where the next opportunity is going to come from, or you might just land a role in a startup or a big tech. So always make sure you're visible and network as much as possible. Now, transitioning research into production, this will be our main topic for today. And we'll be discussing about like what are the different challenges, what are the gaps, how do we address this gap, and also talk about the what to avoid, what worked in a case study for me, what didn't work, and what are the action items that I've taken, and basically how to get a good research into production. So let's talk about, for example, like we want to transition a research into product. What sort of technical difficulties that we see? Because production, I mean, like prototype coding is always done like using POCs. We use in Python or any libraries. We just use like basically a Streamlit app or some other app to build a UI, and backend is going to be like very basic, right? So we don't think about a lot of benchmarking, and because the benchmarking in research is always done on a particular small set of data sets, and it's not like that in real world. So there'll be a lot of real world noise, could be multimodal, messy data, a lot of other stuff. So we need to monitor these gaps, observe these, and because these are like some of the blind spots that we see. So basically, monitoring and observability also is very important when you are taking things into production. Also, having a human in the loop really helps, but we'll definitely talk it in the next slides. All right. So again, coming back to this, what are the main differences in research and production? So if you think about data perspective, you have small data sets. Maybe you could generate some synthetic data set, but real world data is not like that. In production, it's going to be messy, and it's always changing. You don't know which region you're handling. You don't know what's the distribution of the data like. So it's all different. The metrics, benchmarks, everything would be different in real world. Now coming to the experimentation. Okay, you have, let's say, n set of controlled experiments out there. But in production, you could have different experiments, latency versus cost versus production, and throughput versus handling the scale. It could be n number of things coming together. And then success metrics. So mostly, I think the research is, the success metric around research lies around data sets, benchmarking, baselining, and then see how we are improving the leaderboard, everything. But in production, it's tied to more of a business value, impact, user retention, trust. So you should make sure if you are building some product, users have to have a retention rate, right? So you have to have active users, daily active users, monthly active users, recurring daily active users, so that you know your product is doing well, people like to use your product more. So that those are success metrics, and eventually that translates to business value and impact. So to conclude, a great research model might not be a great product. It's not directly equivalent. You need to do a lot of work around it. That's where the productization comes in. So you have productization from some time, like ML productization, software productization. Now it's Gen AI productization. That is going to take up, because these roles are important as research, because there are only few people that could actually take research into production at different companies. So you need to have work with these teams to make sure that these products are delivered. Now, let's talk about like 4 pillars of framework for these production, taking a research into product, basically. So let's talk about the fit. First, you need to understand what you are basically building. What's the problem that is being addressed? So make sure you are aligning your solutions with user and business needs. For that, what do? You understand what are the key performance indicators. You understand your success metrics. You understand the user requirements, business goals, and make sure you follow them. Then coming to the second thing, robust evaluation metrics. You need eval metrics because, again, like eval metrics are very important, and you need in 2 stages. One, at every component of your production system, you might need to evaluate individually. Also, you need to evaluate end-to-end metrics. I'll come back to this, what I mean by component level and end-to-end metrics in the next slides. But moving on. So as part of robust evaluation metrics, you also need to use both automated evals and human evals as well. So again, we'll talk about that in the next slide. But moving on to the next one, engineering for scale. So this is a software engineering problem. There's nothing to do with Gen AI, right? So we need to make sure that we are catering to millions of people. So we need distributed systems, load balancing. And if you are building a Gen AI based system, you need to make sure that your ingestion pipelines, retrieval pipelines, and load balancers, scaling, everything is on track for millions of people. And then your feedback and iteration is the 4th pillar. Because Gen AI is moving so fast, we need to implement fast, and we need to test it out fast. We need to improve it fast. So this whole loop of feedback and iteration has to be really quick. And how do we leverage it is really important. How do you build different components around it to leverage this? One example could be A/B testing, but it's not just A/B testing. We could do a lot more things there. We could establish some feedback loops, and then basically we do a lot of iterative testing there. But we'll talk about it. Now, from so far what we've covered, these are some of the general AI production challenges. It doesn't relate to any product or specific product, but it relates to general AI production challenges. Problem product fit, data and eval gaps, engineering for scale, and reliability, safety, feedback iteration, basically cross-functional complexity. So these are general challenges, but we'll address them. We'll see how each one actually works, and then what you could do to overcome them and build a good product in the end. For that, I thought it would be good to actually take a case study and explain the issues that, as an industry person, what would be the issues that you could see when you're trying to build a production rack system. You might have built one already because it's been there for a couple of years now. Either you could might have built a RAG system that in just a couple of documents answers a question, asks a question on it, and then it generates an answer. But everyone has their own way of building it. Like some people take it to a next level. Some people just do a POC. Some people might just use a local vector database. And some people might just deploy it. But there are so many factors. when you're deploying it for production scale, and we'll talk about it. So again, I'm assuming that everyone has an idea on rack system, but if you don't have idea on rack system, I'll just give you a brief intro. So basically, RAG is retrieval augmented generation. So let's say you have, the LLMs have a context window. So and then we can't just pass a whole context to the LLM, if because that will be too expensive. So what retrieval augmentation generation does is retrieval does is it takes in your input question and matches and gets a relevant chunk of text, and it only passes those chunks of text, rather than passing the whole context, thereby reducing the cost and of the context window. This is very high level, but we'll get into the depth a little later. Now, so if you want to build an enterprise scale document QA system, think about it. You're not just supporting basic text in the documents. You need to support images. You might need audio. You might need video. You might need to handle different complexities in documents, right? Because imagine that there's so much of unstructured data out there. Every enterprise needs some sort of rack system in their entire product. So that's where we'll talk about the production rack system and how Web is able to deploy a low latency system, and what are the key learnings that I have over time. So first thing, so basically what worked for me, right? Make sure your architecture is modular and extensible so that like a lot of teams can actually contribute to it. Basically also it's a good idea to build frameworks from scratch. Frameworks such as agentic frameworks, you could just go with LangGraph, LangChain, Llama Index, the orchestration frameworks, and then there are other frameworks that you could use. Or you could basically build your own framework, or rebuild or customize these existing frameworks to work with your use cases, because every use case will be different. And industry generally tends to reuse the existing frameworks and build on top of it. And scalable infra and tooling, because the infra is already in place, right? We have cloud computing, we have GPUs, we have scalable infra, we have tooling for capturing the analytics, capturing the user feedback, capturing the evaluations and everything. And then coming to people and process, right? So we know what we are building basically, and we have a strict timelines. Okay, this is what we want to deliver in the phase 1. This is what we want to deliver in phase 2. And also working with different teams like data engineering team, analytics teams, different cross-functional teams, and that alignment is very important, because not one team can build an entire product at scale, because there'll be so many teams in big tech. If you're thinking about big tech, startups do operate very lean, but the whole idea is to get into that scale. It's always as you scale the product, the number of people in an industry, be it startup or be it big tech, always increases. They're directly proportional. So that's definitely needed. And change management and rollout strategies is what I was talking earlier. So make sure you're rolling out in phases, so you collect feedback quickly, iterate quickly, and then deliver quickly, and which leads to impact. And then finally, we'll talk about evaluation and feedback. Monitoring the user analytics, why, when, how your user dropped from my product, what did they not like in the product, what they loved about it, what can we do to improve it. So that's where evals, monitoring, and analytics comes in place. So basically you collect quick feedback, iterate, and make sure you're also using some human evals and human in the loop, so you know that you are not biased. Evals might tend to get biased generally, because most of the people out there are actually using ML-based evals, LLM-based evals. Some are using classification-based evals, some are using LLM as a judge, and LLM-based evals, like mostly prompt-based evals. So there will be always bias if you use the same model and to generate, and same model to evaluate. So there's always a bias. So that's where the LLM as a judge itself started. We'll talk about that. And so what did not work? So initially there are so many technical gaps, like latency, cost underestimation. Since the scale is huge, you also need to make sure your latency should be low, because let's say if user enters something, they should expect an answer, or they should expect an outcome within like few milliseconds or maximum few seconds, right? Depending on the task. But let's say if the latency is huge and that's the biggest factor, user will just drop out of the product. So make sure that goes well. And then because the LLMs are tend to hallucinate, and there's so many ways could control, but still even after that they still tend to hallucinate and retrieve some retrieve some information that might not be relevant within the documents or within your context. It could just hallucinate from somewhere, and then from its whole world knowledge. And then coming to the evaluation coverage gaps. So that's another problem we saw, right? Because evals are very subjective in nature. So those can't be directly handled. That's where I have to differentiate the evaluation strategies as both subjective and objective. And that's how this can work. And coming to operational gaps, again, early monitoring is very important. I was telling about the analytics, right? So setting up these analytics pipelines, data um, pipelines, like how do you capture this data, send it to understand different types of um, questions people are asking, or what do they require, what is that people looking for. You could collect these from some sort of analytics from the UI itself, right? So understand these, monitor these gaps, and make sure your maintenance is right. But also we are underestimating our maintenance, because it generally takes a lot of time even after you deploy a product. It generally takes a huge effort to maintain this deployed product also. So there'll be like there's so much resistance from the organization, because something new innovative comes in a research. There's a whole timeline that happens from AI taking it to research to production. So there'll be a resistance at each level. For example, you might have a POC. So you need to present yourself like how good this is, how can it create an impact. So because not everyone can understand what you wanted to say or what you wanted to implement. So it's your job to actually push for it, why this adds value, what's the purpose, like what could be the impact. So if you were able to create that pitch of why this change is needed, then you can overcome the change resistance. All right. Okay, just to summarize, what works and what don't. Make sure you're starting small with a simple pilot product, and make sure you have all your success metrics ready, like what's your cost should be of latency should be per each request, or things like that. And then analytics and everything, what's your daily active users number that you're expecting. If you're serving to, let's say, 1 million users, what should be your daily active users count. What these are success metrics that you have to set very early on, so that you know, okay, our product is doing good, or maybe not doing good. You know why it's not doing good, if that in that case. And then basically make sure all your infra is ready, and get the feedback, because subject matter experts, designers, UI designers, UX designers, and then marketing experts, everyone will be on the loop, because it's again like a whole new product that you're shipping. And then make sure you're planning, monitoring everything, because not just code. You can just add few logging statements into your code that could just log the code. But what about like how your models are performing? If you're using classic or traditional ML models, is there a drift out there? Do you need a retraining? Do you need to do some prompt optimizations? Or do you want to change your eval strategies? Like basically, if you're using LLMs to do evals, or do you need to actually change these prompts? What's the level of effort there? Understanding, planning, monitoring is really important as well. And also, I was mentioning earlier, do a phased rollout, phase one, phase two, phase three, and gradually increase the user count so you know what's going well and what's not. And then make sure, as you know, research is always a good thing. Research to so kind of collaborate with research, product managers, product teams, infras, subject matter experts, and engineering, other engineering teams. So this is how generally any tech firm, be it a startup or be it mid-size or a big tech, generally works on a very broad scale. And then most of the common pitfalls, I think I've already discussed about hallucinations, um, complexity, underestimating the complexity, latency, cost trade-offs. We are only should not never only look at just benchmarks, but also we should look at real world data. And mostly, for example, let's take this thing, skipping edge cases, right? For example, let's say if you're building that question answering system, you always, if you are building it on your own, you don't uh, consider the nested tables. That could be a edge case, right? And then imagine you have like a 500-page document. How do you process it? And then imagine you're not just serving English or US, right? You are serving entire world. You could serve German, you could serve Spain, different languages. So how do you handle multilingual? So these are the cases that one needs to consider when actually deploying into production. Um, all right, let's move to next slide. All right, since we were talking about RAG pipelines earlier, most of the challenges slides around like 3, 4 different areas. One could be the ingestion challenges, data ingestion, like how do you handle different diverse types of data, text, audio, video, tables. How do you chunk it? What's your chunking strategy looks like? Is it optimized? Are you just using the regular chunking strategies provided by different frameworks? Or did you come up with your own chunking strategy for different elements? So again, what's your retrieval challenges? This because retrieval is really a key, because that's where the whole context is, right? So you need, if you are not evaluating how good your retrieval is, then I would say the entire end-to-end metrics actually drop by a lot. And then coming to generation, generation is also important because we should make sure that the answer is grounded and not hallucinating. Also, this is very important in sectors like healthcare and legal tech, right? Because there's 0% chance, like it should be like a zero or almost close to zero. The hallucination rate has to be almost close to zero because there's no gap for that. All right. Let's talk about evaluations, since we were also mentioning that, like, within the case study, how where this evaluation comes into play, and then how could you actually do continuous improvement. Since we are talking about Q&A problem, like you build a question answering system, maybe a question answering system, some chatbot, like, or you could build a search retrieval engine. All these metrics will be common to any of the product that you'll be building, because all of these lies around retrieval, right? So pre-RAG, it's all about retrieval, search, retrieval recommendations. But people are moving towards building a lot of retrievals in their different pipelines. Like one could be a question answering pipeline, a summarization, or multimodal pipelines, multimodal summary pipelines, Q&A pipelines on a video. There's so many use cases out there that you could do just with this one single use case, right? Now, coming to the metrics, how did I evaluate, and what worked for me for a continuous improvement? So few key metrics for evals, right, would be like answer relevancy, context recall, precision, faithfulness. These are some of the common metrics, right, for the RAG. And then apart from that, you also have to do some sort of human in the loop evals. Like we have to make sure that how people could say, like, how good the response is. If it's a search system, how good the relevant results are. If it's a question answering system, how good the answer is. What's the quality like? What's the length of the answers like? Is it comprehensive? Is it concise enough? You could calculate different dimensions to it. So that's where the subjective evals that's where the evaluation is actually subjective. All right. Let's move to the next slide, which talks about the subjective nature of evals. One of the thing is for evals, doing any evals on any Gen AI product is it requires domain expertise. You need ground truth for it. And you need, because user preferences might vary, it's hard to evaluate on any use case. But so with that saying, the problems are it's not scalable, it's time consuming, and it's definitely costly, because putting for subjective nature and evaluating, let's say instead of just 100 records, if you're evaluating 1,000 records, I think the cost definitely is going to scale. Then what are the solutions basically? So make sure you have your automated data pipelines set up, done. Could be simply an LLM as a judge. So that covers like 3, 4, or 5 or n number of LLMs, that whatever you want. And then you could write your own formula to do a weighted average, or basically you could, yeah, basically you could just rely on just an average of all the different models or different LLMs. And then human in the loop evaluations are really important, as I was telling earlier, because humans do have, which gives you a perspective like how the real product would be received, because they are not biased. They can evaluate multiple dimensions to each of the response. If it's a question answering system or search system, they can actually evaluate. They can provide the feedback. They can give a scale, give a rating of 1 to 5 or 1 to 10, however the Likert scale is, and make sure you have proper definitions of each one in the Likert scale. What does 1 mean? What does 2 mean? What does 9 mean? And so this is really important if you're setting up these evaluation loops. And then A/B testing. You could do like different A/B testing strategies, and that can actually help. So maybe control group and A has really good results. All right. Again, I was talking about earlier, I was talking about a lot of evaluations at components level. So what do you mean by component level? So imagine that within just a simple RAG system, we have options to choose like embeddings, search mechanisms, re-rankers, and different sort of LLMs that we could use to generate answer. So how, because changing every component in each stage, you could have a number of possibilities. So how do you basically choose? How do you evaluate? How do you choose and how do you evaluate the systems? Because no one size fits all, right? So that's where you need to do some experimentations, and experimentations with assumptions, and see how your baseline is improving overall. All right. So with that, I think we've almost covered the basic practices, best practices for RAG pipeline, ingestion level, retrieval level, and generation level. So this case study is just to provide you information of how industry people think when they're looking at building a product. So that opens up a lot of knowledge around how you think, what sort of framework you think around. And let's say if completely building a different product altogether in an e-commerce that's not at all related to RAG, that might be related to search recommendations or maybe something else, or you're building a multimodal system. So even if for that, you have to think about few things that I've covered over the time. So again, getting back to the best practices of RAG pipeline, right? In my case, what challenges I faced, and then what are some of the practices that I have taken to make sure they're working fine. Then first thing would be, I was already telling, right, about the different type of chunking strategies, parallelly processing to make sure that the ingestion timelines are low, and then improve your retrieval strategies, develop some advanced strategies, use some advanced strategies, hybrid searches, wherever possible, based on the context length, and then query reformulation. See if you can reformulate your input query to make it better, so that the relevant results are looks good. The re-ranking strategies as well. And then for generation part, mostly it's about Either you could have a proper structured outputs, and then make sure you are either doing a good working on good prompts to generate good answers or good responses. Make sure if you are working on a different domains, make sure you're also using that domain as part of the prompt, so you know you're getting a better answer. But do you think are these enough? Just these three: data ingestion, retrieval, and generation? Definitely not. Like, imagine as a production system, there'll be a lot more components to it. So first thing would be like data sources, ingestion processing. There'll be a storage layer, and then there'll be LLM gateway that controls all the input, output, LLM calls, context, everything. And then there could be a query optimization and input guardrails where, if you are sending some sort of information that has to be blocked, input guardrails is going to take care of that. And handling PII data, that's pretty important at industry level. And also, your how do you build your retrieval generation pipeline matters, and evaluation and continuous improvement, analytics, and logging the telemetry for entire process, and A/B testing. Again, these are some of the high-level components that will be present in just this production RAG system. But imagine if RAG is just a part of your entire system, how big these production systems are going to be. What other metrics or what other optimizations have to be done before you are deploying it to the scale. And then that's the impact that everyone is trying to create. All right, with that, we'll just move and see just for this production rack, how are we doing now? And then basically what's next after, let's say, production rack, if you want to build your multi-agent system. I'm not covering it today, don't worry, but it's just like, let's say if you are in a multi-agent system, RAG is just a small part of it. So basically we're talking about, we can talk about that in coming talk, but today it's about understanding and how these production RAG systems generally work, what people consider in production, what components do people consider in production. So this is a very high level diagram, understanding different components that we spoke about. Imagine that you are uploading 10 documents, 3 audio files, 2 video files, and maybe of 2-3 Word docs. So how do you ingest the data? That's where your transformation loading comes into play. Parsing, chunking, even it's multimodal, it's going to take care. And then embedding them, chunking them, adding some metadata to it, storing in vector DB. All these things will be a part of data ingestion and storage layer. So storage layer not just have normal DBs and document DB, vector DB, graph DB, but it also has analytics to it. You also have feedback database, user history, because this is really important. If you're trying to personalize the user's journey, it's really important to have user history. And this will be a storage layer. And then coming to LLM gateway, these have different models for different providers. It could be like open source provider, open source models. It could be hosted on your system. It could be enterprise models, Cloud, ChatGPT, from OpenAI, anything. It could be anything. And for this, we will definitely have some RPM and TPM limits. So that's definitely important to consider. And then also regarding the backend type of API service, we have different re-ranking strategies, generation and output guardrails to make sure that you're not generating harmful content. And then apart from this, whenever you generate anything out from the service, it's not just at one place you have to record or evaluate, right? As I was mentioning earlier, at each component you have to evaluate. So that's where your evaluation and data flywheels comes in. And there are already few frameworks that you could basically reuse or build on top of. For example, for RAG, it's Ragas. And for observability, there are a few frameworks like Phoenix, Galileo, and other things. So you could actually take that, customize it, add your own evals to it, and that is definitely possible. And then for observability and monitoring, you can use OTel, Open Telemetry. It's an open source one. you have Splunk, Grafana for logging and everything. And make sure all these evaluations and analytics also happen asynchronously. Um, Again, because these are there are two types of metrics, online and offline metrics. So these will be part of online. So because you are evaluating the users responses, make sure you're doing it in a right way and you're not capturing the data. So that's another part. But imagine that there are so many components in just a RAG system if you're trying to just build a product RAG for production. So if you're building a multi-agent system, that will be in another level where this RAG itself will be, let's call it an agent, RAG agent. And then, so this whole thing has to work with other agents as well. So let's not go there, but we'll be covering that in the next topic. So yeah, so that's all for today, but we'll do some key takeaways for today's session. So basically, always problem solution fit comes first because that's very important. You know what you're building. And then evaluation strategies has to be in place even before you're building product and scaling it. Make sure your infra is ready. You should be able to handle scale, load balancing, and everything. Get early reviews as much as possible if you're taking research to product, because the human in the loop is definitely needed to get quick iterations. If you're delivering it as a product from research, it's always good to have guardrails in place so that you make sure there are input guardrails and output guardrails and content moderation, policy classifications, and other necessary things, so that people just try to basically hack it. So just make sure these guardrails are in, and then make sure you're doing continuously improving your product and iterating on top of it. And it's always an iterative process. The new research comes to product, tries to productize it. So it's always an iteration and improvement. So there's never ending a loop. And yeah, that's all for today on productization. Feel free to connect with me on LinkedIn. And if you have any questions, this is the time.
Thank you so much, Nikhil. It was a very informative session. I guess I'm opening up the floor for questions. So feel free to raise your hand and just start asking away. I'll wait for a minute because I have a question too, so I'll ask if no one else wants to.
Yeah, maybe I could just start off. So yeah, you like since you talked about metrics and evaluations a lot, so I was wondering, and we know there's a lot of hype around leaderboards and the leaderboard illusion and things like that. So within a company, how do you kind of like connect these like offline metrics to business KPIs so that teams don't just like chase numbers, but actually see the product market fit and things like that?
Yeah, that's a good question. So basically, it's just not about numbers, right? Initially, we might have some baseline numbers, but again, I was telling you about it. There are so many human in the loop evals as well. So we take both humans in the loop into consideration as well, because that's where the real world people will look like, right? So they're real humans. So we need to understand what these responses will look like, how we are evaluating, what sort of different metrics. Like for example, accuracy could be one, response quality, comprehensiveness, conciseness, the length, did it miss anything, did it cover, what's the coverage like. These are all different dimensions to each of the response that you're evaluating. So definitely human evaluations makes more sense to me here. And since you asked about how do you translate it to business outcome, like let's say there should be some sort of acceptable criteria. So whenever you are shipping something, LinkedIn faces, right? Make sure that you don't degrade much. You have some sort of acceptable criteria, either ±5, ±6, ±10. Make sure if you're in within that range, you should be okay, given the bias from the humans and from the LLMs.
Yeah, great. Thank you for that. In the comments, we have one question. How good is the LLM as a judge strategy? Does it need a better LLM compared to the one we are evaluating?
Okay, so if I get it right, so basically, let's say if you're building a model on using GPT-4o, and it's not a good idea to evaluate just using the same GPT-4o model. So it's good to maybe evaluate it with Claude, Opus, or different models, or any open source models, and then take an average of it. Either you could just do that way, excluding the model that, for example, if you're in GPT-4o, you could just use other models to form LLM as a judge. Or if you're including GPT-4o, you just have to give a weighted score of less weighted score to it, and then more weighted scores to the other models. So that way, you're not completely biased. Because if you're generating using GPT-4 and if you're evaluating using the same, there'll definitely be a bias, and you always get scores of 4 and 5 on a scale of 5. So it's a bad idea there. But definitely that LLM as a judge strategy works. Just make sure whatever model you are using to for inference, it's not there as part of eval. Yeah.
Yeah, sounds great. So my question would be, so you talked about how latency is a very crucial factor to productionizing your product, like from the research steps to the end. And I have like firsthand experience of this. So I'm also an AI engineer at a startup, and although my role is pretty small, we deal with these concepts on the daily, so I can relate with a lot of the things that you've mentioned. So one thing that we struggle with even now is latency, right? So getting that number down sub 1 second, sub 0.5 seconds, getting TTFT as quick as possible, right? So for us, what we kind of sort of through experiments and trial and error, what we figured out was closed source is definitely more latency consuming than open source, because open source we get to host on our own GPU or server and we get it running. But are there any other tips that you can provide, maybe that has proven to reduce latency, or just in general get a better, efficient solution pipeline running?
Yeah, it's always good to have, but that's a good question. It's a real problem, and I'll also talk about what's happening with the agents as well. But what's happening with the latency systems, like you measure different percentiles, right? Let's say you have measured P50, P90, P99, different latencies. Again, let's consider you're measuring P75 latency, and make sure in your system, wherever you need an LLM, based on the use case. For example, if it's a simple LLM call or simple judgment that you need to make, you don't need a powerful model, right? You could use with something like Nano or Mini. For example, I'm just talking about GPT-4, but let's say if you're open source model, you could go with a 7 billion parameter model. So the only optimizations I would say is either for an open source model, it's definitely true. Inference, you could optimize as much as possible. But even with that, enterprises tends to generally go with closed source models, and because we have generally all the enterprises generally have like provisioned throughput units, and so they have a reserved access to these GPUs from maybe OpenAI or Claude. So we have reserved instances that keeps running, and that's where the latency definitely you could is better than that running it directly. Also, it's kind of reserved, so it also makes sure the region takes care of region everything. The only thing to consider here is depending on the type, the intent, you just have to route it to the right model, and that actually helps you increase overall latency. But apart from that, like making asynchronous calls using cache mechanisms, prompt caching, all these actually help to some extent.
Yeah, great. Thank you so much.
Yeah, thank you. And agentic systems are yet like increasing the latency yet. I mean, like that's a opposite direction we are going, but we have to see how these things turns out, because everyone is doing more thinking now. So which definitely has a lot of latency. But if this whole industry is moving towards there, again, completely, even GPT-5, if you look at it right now, you ask a question, there's an option, get an answer quickly.
Yeah.
It always is thinking. Basically, it's taking 20-30 seconds for any query. There's an option, get an answer quickly. So people are still figuring out what's the best way. Basically, just to either just show the answer right away, or think properly, give an answer, or provide both options so user can select.
Yep. Sounds good. Let's hope it gets better soon. Any more questions? I guess not. And I think we're right on time. I guess we'll bring the session to an end. So thank you so much, Nikhil, for your informative session. I've definitely learned a lot from the session, and there were many parts that I could relate to as well. So overall, I believe this has benefited the overall crowd, despite most of them being students or early career professionals. I hope everyone got a takeaway from this. And we'll be coming out with more sessions like these. So hopefully you've entered your input in the poll, and we can tailor our next session accordingly. Thank you so much for joining, everyone. Thank you for your time, and see you next time. Bye-bye.
Thank you so much. Bye, everyone.